Okay, hello, welcome to my channel. You're welcome to the day 21st, all right, of our 30 integrals in 30 days. It's sad. I wanted to take questions from you, all right, from the day 21st to the day 25th, but this is the day 21st, and I haven't received any question from anybody. I don't know if you got it, all right. I talked about it in my last few videos from day 17, 18, 19. All right, that I want to entertain questions from you from the day 21st, and this is the 21st. This question, I just brought it up as usual, all right, because nobody has given me a question to solve. But I want to hope that from day 22nd, which is going to be the next video, somebody would give me any integral questions in the comment section, and I'm going to do that. So just go ahead, write down any integral questions, all right, that you want me to find or to solve a solution like this in the comment section, and I'm going to pick it up, all right, from the 22nd to the 25th. Okay, great. Okay, let's just go ahead and look at this integral problem. Well, it's not that easy if we want to look at it in different ways. There are different ways we can take this integral, right? But I'm just going to use the trick right here. So let's start off by now looking at this, the integral of secant of x. Okay, maybe I can start off by rewriting secant as 1 over cosine, right? Because that's what it is. And then from the 1 over cosine, I'll try to do some stuff which will make us arrive at a fraction where we need to decompose into partial fractions, and from there we will get the result, right? But let's just do the trick. Let's just do the shortcut, all right? The trick form. Okay, great. When I say trick, I don't mean trigonometry. I mean like trick magic. Okay, great. So let's go ahead and say that this is the same thing as, well, first of all, I'm going to rewrite this integrand. The integrand, I mean the function we are integrating. Okay, great. So I'm going to do that by multiplying this integrand by 1. And the version of what I'm going to multiply it is secant of x plus tangent of x. So let's put down the secant first. Right? Then I'm going to multiply this by 1. By multiplying a thing by 1, right? It is the same thing as saying let's divide the numerator and denominator by the same thing. Okay, so I'm going to divide the numerator and denominator by the same thing. And that is the same thing as saying you are multiplying it by 1. Okay, great. So what are we going to multiply top and bottom with? Well, let's multiply top and bottom by the secant of x plus the tangent of x. Alright, so let's do that to the bottom as well. Secant of x plus the tangent of x. Okay, very nice. So as you can see, this divided by that, since they're exactly the same, the ratio will just give us 1, and we multiply with secant. Of course, we have the original function. Okay, so let's equate these two. Well, you notice that if you multiply the numerator out, you're going to have secant squared of x, right? That is the square of secant x plus secant x times the tangent of x times the tangent of x. And then we divide this by what the denominator, which is just secant of x plus the tangent of x, and then we put the dx over here. Okay, I still have a little room at the bottom. I think that should take care of the answer. And this is how the answer will be written. Well, the answer will just be the ln of the denominator. That is, the result will just be the ln, the natural logarithm of, well, the denominator. Okay, so you notice, since we are done, we can just add an arbitrary constant. And let me explain this a little bit. Now you notice that this is plus c, right? Okay, great. Now you notice that this denominator, if you differentiate the denominator, is going to give us the numerator. The derivative of secant of x is secant x times the tangent of x, while the derivative of tangent of x is secant squared of x. So if we have the antiderivative of a function where the function is the derivative of the denominator, right? Okay, so if the numerator is a derivative of the denominator, then the result is going to be the ln of the denominator, right? And then we can add an arbitrary constant. So given that, that means that since the derivative of this denominator is equal to the numerator, the result is going to be the natural logarithm of the denominator. And as you can see, I'm putting this in absolute values because the natural logarithm only exists when the domain is positive. All right, so this absolute value will ensure that we have a positive outcome from this sum, and then we add an arbitrary constant as usual. All right, great. Okay, so that's it using the trick version. Thanks for watching, and please do well to put your questions down below, right? And I'm going to treat it from the 22nd and so on and so forth. All right, thanks for watching, and please subscribe to my channel.